Python did not appear suddenly. It has a very interesting origin story that explains why it feels so simple and human-friendly today. Python was created by a programmer named Guido van Rossum in the late 1980s and officially released in 1991. At that time, Guido was working at a research center in the Netherlands, and he was using a language called ABC. ABC was designed to be easy, but it had many limitations and could not solve real-world problems effectively, so Guido decided to build something new, a language that keeps simplicity, but also gives real power and flexibility, and that idea became Python. Now, you might wonder why the name Python. It was not named after the snake. Guido was actually a fan of a British comedy show called Monty Python Flying Circus. He wanted a name that feels short, unique, and a bit fun, so he chose Python, and this also reflects the language style: simple, but enjoyable to use. From the very beginning, Python was designed with a clear philosophy. Code should be easy to read, easy to write, and easy to understand. Guido believed that programming should not feel like solving a puzzle every time you write a line of code. Instead, it should feel natural, almost like writing instructions in plain English. This is why Python uses clean syntax and avoids unnecessary symbols. For example, instead of using brackets everywhere, Python uses indentation to define blocks of code this small. Decision makes code look clean and organized without extra clutter. Another important idea behind Python was portability. This means Python code should run on different systems without major changes. Whether you're using Windows, Linux, or Mac, the same code should work. And this made Python very useful for developers around the world because they did not need to rewrite programs for each system. In its early days, Python was not very famous. It was used by a small group of developers, but over time people started noticing how productive it was because you could write less code and still achieve more results compared to many other languages. This attracted more developers, and slowly the community started growing. A big turning point came when Python began to be used in education. Teachers realized that beginners understand programming concepts faster with Python. Because they do not get stuck in complex syntax, students could focus on logic problem solving and creativity instead of memorizing rules and symbols. This made Python very popular in schools and universities, and once students learn a language early, they often continue using it in their careers. Another major moment in Python history was the release of Python 2000 and Python 3. Python 3 especially improved consistency and removed older limitations, making the language cleaner and more future-ready. Even though the transition took time, it helped Python grow stronger in the long run. As the internet started growing, Python also found its place in web development. Frameworks like Django made it possible to build powerful websites. Quickly, companies started using Python for backend systems and automation tasks because it saved time and reduced development cost. Then came the data revolution. When companies started collecting huge amounts of data, Python became a natural choice. Because of its simplicity and powerful libraries, tools like NumPy, Pandas, and Matplotlib made data analysis much easier compared to other languages, and this pushed Python into the spotlight again. Later, artificial intelligence and machine learning took over, and Python became the leading language in that space. Libraries like TensorFlow, PyTorch, and scikit-learn made it easier to build intelligent systems. And since Python was already easy to learn, many people entered the AI field through Python, which increased its popularity even more. Today, Python is used by some of the biggest companies in the world, including Google, YouTube, Netflix, and NASA. They use Python for different purposes like automation, data analysis, web services, and machine learning. This wide usage shows how a simple idea from one developer turned into a global standard. So the origin of Python is not just about when it was created, it is about the vision behind it, a vision to make programming simple, powerful, and accessible to everyone, and that vision is the main reason Python continues to grow even today. Now let us understand the real reason Python did not just grow slowly, but actually exploded in adoption across the world. And the answer is not only technology, it is a mix of education industry needs and job market demand, all working together in the right time. First, think about education. When schools and universities choose a programming language, they look for something that is easy to teach and easy to understand. Python fits perfectly here because students can start writing useful programs from day one without spending weeks learning complex rules. For example, a teacher can explain loops using a simple Python line like for I in range 5 print I, and students immediately understand what is happening. There is no heavy syntax blocking their learning. This creates a smooth entry into programming, and once thousands of students learn Python every year, it naturally becomes the language they carry into their future careers. Now look at online learning platforms and tutorials. Most beginner courses use Python because it reduces frustration and increases progress speed. When learners see results quickly, they stay motivated and complete courses. This creates a huge number of Python learners globally, and many of them become developers, data analysts, and engineers later. This continuous flow of new learners is one of the strongest forces behind Python adoption. Now move to the industry side. Companies always look for two things: speed and cost efficiency. Python helps in both areas because developers can build applications faster with fewer lines of code. For example, if a company wants to automate a daily task like reading files, generating reports, and sending emails in Python, this can be done in a short script using built-in libraries, while in some other languages it may require more setup and time. This means companies save money and deliver results faster, so they prefer Python for many tasks. Another key factor is versatility. Python is not limited to one field. It is used in web development, data science, automation, artificial intelligence, scripting, testing, and even cybersecurity. This means a company can use one language for many different purposes instead of training teams in multiple languages. For example, a startup can build its website backend using Python, analyze user data using Python, and also automate internal processes using Python. This reduces complexity and increases productivity. Now think about the job market. When companies start using Python more, they need more people who know Python, and when more jobs require Python, students and professionals start learning it to stay relevant. This creates a powerful cycle. Demand creates learning, and learning creates more supply, but the demand still keeps growing because new fields like AI and data science are expanding very fast, and Python is at the center of these fields. Let us take a real-world scenario. A data analyst in a company needs to clean and analyze thousands of rows of data. Using Python with pandas, they can load a file, filter data, calculate results, and even create visual charts in a short time. This ability to handle real-world data quickly makes Python a must-have skill in many jobs. Now, compare this with doing the same work manually or with less efficient tools. The time difference is huge, so companies actively look for people who can do this with Python. Another strong reason is community support. Python has one of the largest programming communities in the world. This means if you face a problem, there is a very high chance someone already solved it and shared the solution online. This reduces learning time and helps developers work more efficiently. For example, platforms like Stack Overflow, GitHub, and many forums are full of Python examples, tutorials, and ready-to-use code. The support system makes Python feel easier compared to languages where help is limited. Now consider open source libraries. Python has a massive collection of libraries that are free and ready to use. Instead of building everything from scratch, developers can simply import a library and use it. For example, if you want to work with images, you can use Open. If you want to build a web app, you can use Flask or Django. If you want to work with machine learning, you can use TensorFlow or PyTorch. This saves weeks or even months of development time and encourages more people to adopt Python. Another important factor is integration. Python works well with other languages and tools. It can connect with C, C++, Java, and even hardware systems. This means companies can add Python into existing systems without replacing everything. This flexibility makes it easier to adopt Python in real-world environments. Also, big tech companies played a major role when companies like Google, YouTube, Netflix, and Facebook started using Python. It gave confidence to the rest of the industry. People trust tools that are used by successful companies. So this created a strong signal that Python is reliable and scalable. Now think about automation in daily work. Many professionals who are not full-time programmers also use Python for small tasks like renaming files, processing data, or scraping information from websites. Python becomes a practical tool, not just a developer language. This expands its user base beyond traditional programmers and increases adoption even more. So when you combine easy learning, strong presence in education, high demand in jobs, powerful libraries, large community, and support from big companies, Python becomes almost unstoppable in growth. It is not just a trend, it is a result of many systems working together at the same time. Now let us go deeper into the technical strengths of Python and understand why developers prefer it over many other languages when it comes to real work. One of the strongest features of Python is readability, which means the code looks clean and easy to understand. Even for someone who did not write it, this is very important in real projects because code is not written for machines only, it is also read by humans. For example, in Python, if you want to check a condition, you can write if age is greater than 18, print adult. This almost reads like a normal sentence, while in many other languages you will see extra bracket symbols and semicolons that make it harder to read at a quick glance. This clarity reduces confusion and helps teams work better together. Another important strength is fewer lines of code. Python allows you to do more work with less code. For example, if you want to filter even numbers from a list in Python, you can write a simple list comprehension like numbers equals list, and then even numbers equals for each number. If number mod 2 equals 0, this single line replaces multiple lines of loops and conditions. In other languages, less code means fewer chances of errors and faster development, which is very valuable in real projects. Now let us talk about dynamic typing in Python. You do not need to declare the type of a variable before using it. You can just write x equals 10 and later x equals hello, and Python will handle it. This makes coding faster and more flexible, especially in early stages of a project. While in languages like Java or C++, you must define types clearly, which adds more work and reduces flexibility. This is one reason Python is great for prototyping, where speed matters more than strict structure. Another key feature is built-in data structures. Python provides powerful and easy-to-use data structures like lists, dictionary sets, and tuples. For example, if you want to store key value pairs, you can use a dictionary like student name equals Ollie, age equals 20, and access values quickly using keys. In other languages, you may need extra setup or libraries for similar tasks. These built-in tools make Python very practical for everyday programming. Now think about libraries and ecosystem. Python has one of the richest ecosystems in the programming world, which means you can find a library for almost anything. For example, if you want to send an HTTP request, you can use request library. In just a few lines, import request, get URL, and print response. If you want to work with dates, there's a library. If you want to build games, there's a library. This huge ecosystem saves time because developers do not need to reinvent solutions. Another powerful strength is cross-platform support. Python code can run on different operating systems without major changes. This is important for companies that work on multiple platforms. For example, a script written on Windows can run on Linux servers with little or no modification. This reduces effort and increases flexibility in deployment. Now let us talk about automation, which is one of Python's strongest areas. Imagine you have a folder with 1,000 files, and you want to rename all of them in a specific pattern. Doing this manually will take a lot of time. But with Python, you can write a small script that loops through files and renames them automatically in seconds. This kind of simple automation is very powerful and is used in offices, data processing, and system management. Another important feature is integration. Python can easily connect with other languages and systems. For example, if a part of your program needs high speed, you can write that part in C and connect it with Python. This gives you both performance and simplicity at the same time. This flexibility is very useful in large projects where different tools are combined together. Now let us discuss error handling. Python makes it easier to handle errors using try and except blocks. For example, you can try to open a file, and if it fails, you can catch the error and print a message instead of crashing the program. This makes applications more stable and user-friendly, while in some other languages, error handling can be more complex and harder to manage. Another strength is strong support for object-oriented programming and also simple scripting. Python allows you to write quick scripts for small tasks and also build large complex systems using classes and objects. This balance is rare because some languages are good for small scripts and others are better for large systems, but Python handles both very well. Now consider testing and debugging. Python provides simple tools to test and debug code. Developers can quickly find issues and fix them, which improves productivity in large projects where debugging can take a lot of time. Python simplicity becomes a big advantage. Also, Python has a strong standard library, which means many useful features are already included without installing extra packages. For example, working with files, handling JSON data, performing mathematical operations, and even basic networking can be done using built-in modules. This reduces dependency on external tools and makes development smoother. So when developers choose a language, they look for something that saves time, reduces complexity, and allows them to build reliable systems. Python checks all these boxes with its readable syntax, powerful libraries, flexibility, and strong ecosystem. This is why it is preferred not only by beginners, but also by experienced developers working on serious projects. Now, it is important to be honest because no programming language is perfect, and Python also has its limitations. Understanding these limitations will give you a complete and realistic view and also help you decide when Python is the right choice and when another language might be better. The most common point people raise is speed. Python is slower compared to languages like C and C++. This happens because Python is an interpreted language, which means code is executed line by line at runtime, while languages like C are compiled into machine code before execution. For example, if you write a program to perform millions of calculations in a loop, a C program will usually run much faster than a pure Python program. This makes languages like C and C++ better for tasks where every millisecond matters, such as game engines, operating systems, and real-time systems. However, this does not mean Python is useless for performance-heavy work. In real project, developers often use a hybrid approach. For example, they write the main logic in Python and use optimized libraries written in C underneath, like NumPy for numerical operations. This way, they get both ease of use and good performance. So the limitation exists, but there are practical ways to handle it. Another limitation is memory usage. Python generally uses more memory compared to lower-level languages. This is because it stores extra information about objects and handles memory automatically. For example, if you create a large data structure, Python might consume more memory than an equivalent structure in C++. In small programs, this is not a big issue, but in large-scale systems or embedded devices, where memory is limited, this can become a concern. Now let us talk about mobile and front-end development. Python is not a strong choice for building mobile apps or running directly in web browsers. JavaScript dominates the front-end world because it runs natively in browsers, and languages like Kotlin and Swift are preferred for mobile app development. Python can still be used with some frameworks, but it is not the first choice in these areas. This is why developers often combine Python with other languages depending on the project needs. Another point is global interpreter lock, often called GIL. This is a technical limitation in the standard Python implementation, which affects multi-threading. In simple words, it means that only one thread can execute Python bytecode at a time, even on multi-core processors. For example, if you try to run multiple CPU-heavy tasks in parallel using threads in Python, you may not get true parallel performance like you would in languages such as Java or Go. However, this issue can be managed using multiprocessing or external tools. So again, it is a limitation, but not a complete blocker. Now consider large-scale enterprise systems. Languages like Java and C# are often preferred in very large enterprise environments because they offer strong type systems, strict structure, and long-term stability features. These languages help manage very big teams and complex codebases. Python can still be used in large systems, but sometimes companies choose more structured languages for better control and maintainability over many years. Another limitation is runtime errors. Because Python uses dynamic typing, some errors appear only when the program runs. For example, if you try to add a number in a string, Python will show an error at runtime, while in statically typed languages like Java, this error will be caught earlier during compilation. This means developers need to write good tests in Python to avoid such issues. Also, packaging and dependency management can sometimes be confusing, especially for beginners. Managing different library versions and environments may require extra tools like virtual environments or package managers. While this problem exists in other languages too, Python beginners often face it early because they start using external libraries quickly. Now let us compare these limitations with advantages again, because this balance explains why Python is still so popular even with these challenges for most applications like web development, data analysis, automation, and AI. The speed of development and ease of use matter more than raw execution speed. Companies prefer to deliver products faster and improve them over time instead of spending too long optimizing early stages. A simple real-world example: imagine a startup building a data dashboard. If they use Python, they can build a working version in days, test it with users, and improve it quickly. If they choose a lower-level language, they may get better performance, but development time will be longer, which can delay the product and increase cost. In many cases, speed of development wins over speed of execution. So the key idea is Python is not trying to be the fastest or the most low-level language. It is designed to be practical, flexible, and easy to use, and for most real-world problems, this approach works extremely well. That is why even after knowing its limitations, developers still choose Python again and again. Now, after understanding comparisons, origin, strengths, and limitations, the big question is, what is the future of Python? And should you learn it? The answer becomes clear when you connect all the points. Python is not just a trend, it has become a foundation language in the modern tech world. And its future looks stable and strong because it is deeply connected with fast-growing fields like data science, artificial intelligence, automation, and cloud computing. These areas are expanding every year, and Python is already at the center of them. Think about how technology is moving. Companies are collecting more data, building smarter systems, and automating daily tasks. Python fits perfectly in all these directions. For example, in artificial intelligence, most tools and learning resources are built around Python. So new learners naturally start with it, and companies continue using it because the talent pool is large and growing. This creates a long-term cycle that keeps Python relevant. Now consider the learning path. If you're a beginner, Python is one of the best starting points because it allows you to understand programming concepts without getting stuck in complex syntax. You can focus on logic, problem solving, and building real projects very early. For example, you can create a simple calculator, automate file tasks, or analyze data within a short time. This early progress builds confidence and keeps you motivated to learn more. If you're already in the tech field, Python can still add strong value to your skill set. For example, a web developer can use Python for backend services. A system engineer can use it for automation. A data analyst can use it for processing and visualization. And even cybersecurity professionals use Python for scripting and testing. This wide usage means learning Python can open multiple career paths instead of limiting you to one direction. Now let us talk about job opportunities. Python continues to appear in job listings across different roles like software developer, data analyst, machine learning engineer, automation engineer, and more. Companies of all sizes, from startups to large organizations, use Python because it helps them move fast and reduce development effort. This demand is not limited to one country. It is global, which makes Python a valuable skill almost everywhere. At the same time, it is important to stay realistic. Python alone is not enough. You also need to understand concepts, tools, and problem-solving techniques. For example, if you want to go into data science, you should learn data handling, statistics, and visualization along with Python. If you want to go into web development, you should also understand databases and basic front-end technologies. Python becomes your main tool, but your overall skill set makes you valuable. Now think about the balance again. Python may not be the fastest language, and it may not be used for low-level system programming, but it wins in areas that matter for most people: ease, speed of development, flexibility, and strong community support. This is why it is often described as a practical language. It helps you get things done without unnecessary complexity. A simple way to see this is, imagine two developers. One spends a lot of time writing complex code for maximum performance, and the other builds a working solution quickly using Python and improves it step by step. In many real-world situations, the second approach is more useful because delivering value early is very important, and Python makes that possible. So when you look at the full picture, Python's success is not an accident. It is the result of simple design, smart decisions, strong community support, and perfect timing with industry needs. From education to professional work, from small scripts to advanced AI systems, Python has created a space where beginners feel comfortable and experts stay productive. In the end, if your goal is to enter programming, build real projects, explore data, or work in modern tech fields, Python is a very strong choice to start and grow with. It gives you a smooth entry and enough power to handle serious work as you progress. And even if you later learn other languages, the concepts you learn with Python will make that journey easier. And that is the complete story of Python, from its origin to global adoption, its strengths, its limitations, and its future direction. Now you have a clear and honest understanding to decide how it fits into your learning or career path.